All right, so in our last video, we learned about the structure of water, and we learned that because water is polar, it's going to form hydrogen bonds. And we're going to see in this video that because of these reasons, it's going to lead to most of the unique properties of water. All right, so the first one we'll take a look at is called the universal solvent. A solvent is just a substance that dissolves other things. So water is universal. It's called a universal solvent because it's able to dissolve more things than other solvents. To give you one example, salt, table salt, is sodium chloride, and that's an essential nutrient for humans and a lot of animals. But in order for our cells to use it, it has to dissolve into ions. The sodium ion, which is positive, and the chloride ion, which is negative. Let me write that. So ions are charged particles. Like oftentimes atoms and molecules can be ions because they're charged. Right. So let's take a look at how water is able to dissolve a solid crystal like salt into its ions so they can be used by cells. All right, so I'm going to draw a positive ion on one side and a negative ion on another side, and I want you to notice how the arrangement of water molecules is different between the two. So on the positive ion, we're going to draw water molecules where the oxygen side is facing the positive ion. And it has to be this way because it's the oxygen side that is partially negative. So the opposite charges attract, and then it's the hydrogen sides that are positive. So those would be facing away from the positively charged ion. All right, now over here to the right, it's going to be quite the opposite. It's going to be the positive side of the water molecules are going to face the negative ion. All right, so a common test question might, draw an ion and then give you some diagrams where the water molecules are arranged incorrectly, and maybe one of them is correct, and you'll have to choose which one is correct. All right, notice the opposite charges are facing each other. All right, so the next property is we'll take a look at, and these are not in any kind of order, is cohesion. Cohesion is when water molecules are attracted to other water molecules. Water attracts water. And there's a couple examples you should be familiar with that are common. And one is that cohesion leads to surface tension. And that's the phenomena where you have this film, a layer on top of the water that provides a surface for insects to walk on or leaves to float on. And the other one is the phenomena of water beading. Okay, so when water beads on a lot of surfaces, it's that water beading phenomena where water is attracted to water, it pulls itself inward away from the air, which is nonpolar, and that's an example of cohesion. So here is an example of a water strider or an insect walking on the surface of water. Again, that is due to cohesion. Cohesion leads to surface tension. And because water is polar and it forms hydrogen bonds, that leads to cohesion. And so this is really the root of all of these unique properties. Over here to the right, you can see water beading, and that phenomenon is also an example of the cohesion property of water, water attracting to water. Okay. All right, so our next example we're going to take a look at is adhesion. Adhesion is our next property of water. And this is where water attracts other substances that are not water. Water attracts other things. All right, so there's a lot of examples of adhesion. Here's a couple. So when you have water droplets forming, that's cohesion. But when those droplets are sticking or attracted to these leaves are not water, so that is adhesion. And over here, the water droplets attracted to the spider web, that is adhesion. Okay? Again, adhesion, cohesion, all these unique properties are possible because water has these charges on its molecule. We call that polar, and because of that, they form hydrogen bonds. In adhesion's case, it's the hydrogen bonds between water molecules and that other polar substance. All right. So our next one is going to be a result. It's actually not a unique property of water, but it is a phenomena that is caused by cohesion and adhesion, and it's called capillary action. And capillary action is just a phenomena where water goes up against the force of gravity. So we can describe this as water moving upward in plants is where you would find this in biology, moving up in plants. Again, this is caused by both adhesion and cohesion working together. So in this diagram, what's going on is first of all, the water is leaving or evaporates or transpires through the leaves, and what that does is all the water molecules from the leaves all the way down to the roots are kind of connected, and so when one water molecule leaves the plant, the next one is pulled upward. Right, so that's the cohesion. That's the cohesion factor pulling water molecules upward. Now, when this stops, the water molecules don't go back down. Rather, they're also attracted to the sides of the plant cells. We call them, these tissues are called xylem tissues. But when the water molecules are attracted through hydrogen bonds to the sides of the plants, we call that adhesion. So that helps the water molecules from preventing it from going back down. So you can see cohesion and adhesion work together in moving water molecules up, right? Because in plants, water is absorbed by the roots. The leaves don't absorb water, the roots do, and that's in the ground. When that water needs to go all the way to the top of the plant, that's where the photosynthesis happens in the leaves. Okay, so it's really important that we get a process where water moves up plants. All right, and again, that's called capillary action. All right, and capillary action is caused by a combination of adhesion and cohesion, as well as the process of water evaporating. Okay, so our next property of water, our next unique property of water is specific heat. Right, now, specific heat is the water specific heat has a high specific heat is the ability to absorb or lose energy, heat energy, without its temperature changing much. All right, so you can simply state water's, let's do this, water's temperature does not change easily. Okay, and that concept is known as the high specific heat of water. So what I have here is a water balloon. I just filled up, and I have a lighter. I'm going to show this to my students. I put a lighter underneath a water balloon, and I hold it here. I can hold it here all day. I'll probably run out of lighter fluid, but then I'll have a student, feel the water balloon, and they'll say, "Wow, it's cold. It's just tap water. It's cold tap water." And so that's showing you the specific heat property of water. And I can hold a flame under this water, and that temperature of water is not going to change very easily. Now you can imagine if this was not water and rather like a piece of metal, and I heated up the metal, well, that metal would get really hot really fast. So we would say metals have a low specific heat, right? The temperature of metals change very rapidly. So imagine if our bodies were, and our cells were made of metal, we would like freeze in the winter, and we would be really, really hot in the summer. It would not support life. So that's another reason water is key to supporting life. All right, so that's specific heat, and let me give you an example. Actually, another example of how this applies to living things. This is in this illustration you have a bear, but a better illustration would have been like a cold-blooded or ectotherm animal like a crocodile or an alligator. If this was an alligator, cold-blooded animals have to rely on the environment to maintain their constant body temperatures. All right, so how can an alligator stay out in the hot summer heat all day without burning up? Or how can it survive freezing cold temperatures? Not too long, but how can it survive freezing cold temperatures overnight? Well, it's because it can. I know this is a bear, but it would be a better example if it had been an alligator. It can absorb all that heat during the sun during the day, and then that water temperature in that organism is not going to change much. And then same thing when it gets really, really hot, it can stay in a cool environment and then be able to survive that heat of the day, because again that water temperature is not going to change very easily. All right. So we got two more. Next one is the density of water. All right. So water is very unique. Most things when things freeze, they contract. But when water freezes, it expands, and that's very unusual. Right? So freezing causes water to expand. Right? Most things, or things that color, contracts, but water, because of its the arrangement with hydrogen bonds, it causes ice expands, and because of that, right, because ice expands, it floats. It's less dense. And so I'm going to get to why this is important in a minute. Actually, I'm going to get to it now. But because water or ice floats on top of liquid water, that's able to provide insulation in aquatic ecosystems. Okay, so this is just one example of this property. right? But in here, in this lake or pond ecosystem, in the winter, as the temperature drops, okay, some of the water starts to freeze. Imagine if that water started to freeze, like bottom up. If that water started to freeze bottom up, that whole lake or pond would be frozen over, and a lot of the aquatic organisms would not survive. And like our Earth is covered with mostly water. The oceans would freeze over, and life would not look very much like the way we know it. But rather instead, when water freezes, it floats to the top. And so as it gets colder and colder outside, and more of this freezes, then it just builds up a thicker layer on the top. And not only does that not freeze the water below it, but it also acts as an insulator for the water below it. So in this case, the fish, they just simply swim farther down, and again, that's a combination of the specific heat, the water temperature not changing very quickly, but also because of water's density, right? It floats and allows this insulation on the top. All right. So we have one more to go, and this is called the freezing point. The water's freezing point. It's actually boiling point as well, but on tests we are only ever tested on the freezing point property of water with a solute. Okay, so a solute is something that dissolves in water, like sugar or salt. As we went over earlier, a lot of things dissolve in water. In any case, when you have, let's just take a cup of water, and you dissolve solute, right? So solute particles, that is always going to lower the freezing point. Okay, so the standard freezing point of water is 0 degrees Celsius or 32 degrees Fahrenheit. That's when water freezes under standard conditions. But when you add solute to it, that freezing point can get lowered to like negative 10 degrees Celsius or negative 10 degrees Fahrenheit. Depends what you add in there and how much of it you add in there. That's the reason why that's the reason why we add salt to our roads in the winter, so ice does not form at its usual temperature. Rather, it stays a liquid. Right. So what you need to know is adding solute to water always lowers the freezing point. All right, and you'll learn in chemistry why this is the case, but we're not going to get into that in this video.